Which of the following graphs best represent the variation of density of water with temperature? We know that when increase in temperature of water from 0 to 4 degrees, its volume is decreasing. After that, when increase in temperature, volume is increasing. Density is inversely proportional to volume. Therefore, variation of density should be opposite to the volume. We can obtain maximum density at 4 degrees. This one is temperature in Celsius. This axis is density. Normally we are using density of water as 1000 kilograms per cubic meter. You have to remember that 1000 value is this maximum density. Therefore, normally density of water is less than 1000 at room temperature. Because of we can obtain 1000 density only at 4 degrees Celsius. Answer for this one should be 2. 21. 5 identical beakers A, B, C, D, E contains different amount of lead salts and are filled with water to the same level as shown. In which beaker will the water level rise most when heated about 85 degrees Celsius? We have to understand volume expansivity of water is greater than volume expansivity of lead salts. We can get volume expansivity of a liquid is greater than Therefore, we can obtain maximum volume increasement of the system when there is a maximum volume of liquid. Now, maximum volume of liquid is in beaker A. Therefore, we can obtain maximum increasement of volume for the beaker A. Then answer is 1. A uniform cylindrical vessel is filled with a liquid of volume expansivity gamma to a height h naught. The linear expansivity of material of cylinder is alpha. If the temperature of the system is increased by theta, the new height of the liquid level is given by. We can get initial final volume. We can get final volume. V2 should be equals to V1 into 1 plus gamma theta. We can write final volume, final cross-sectional area of the container, A2 into height. And we can write initial volume, initial cross-sectional area of the container into initial height. Now we can substitute final cross-sectional area of the container is A1 into 1 plus 2 alpha theta. We have to use area expansion. Area expansivity is beta. It is equal to 2 alpha. Into H should be equal to A1 H naught 1 plus gamma theta. Now we can cancel out A1 and A1. We have to subject H naught into 1 plus gamma theta divided by 1 plus 2 alpha theta. Then answer is 3. But in third answer, there is a printing mistake. They have given 1 plus lambda gamma theta. It should be 1 plus gamma theta in this case. A mercury glass thermometer has a bulb of volume 0.5 cubic centimeters and stem of internal cross-sectional area 4 into 10 to the power minus 4 square centimeters. If the distance between 0 and 100 marks of the thermometer is 20 centimeters. The apparent volume expansivity of mercury in glass is approximately. When getting apparent volume expansivity, we can consider that glass thermometer is not expanding. We have to consider only the expansion of mercury. We can write delta V should be equal to V1 gamma theta. Gamma value is apparent volume expansivity. For the thermometer, volume expansion, increasement of volume should be equal to volume of this part. Volume between 0 and 100 positions of capillary. Then we can write, it should be cross-sectional area into height. Cross-sectional area is given as 4 into 10 to the power minus 4. Height is 20 centimeters. All values are in centimeters, therefore we can use centimeters value. V1 is the initial mercury volume, which should be equal to the volume of the bulb. Volume of the bulb 0.5. Then we can find gamma value, temperature increasement 100. 0.5 into 150. Then we can get 50 to the left hand side as a division. 50. 0.28 divided by 5, 1.6 into 10 to the power minus 4 per Celsius. Answer is 4. During the formation of ice in a pond, due to cold weather, the possible temperatures at the point A, B, C shown in the figures are. We know that there is a temperature gradient between environment and this water, and we know that we can obtain highest density of water at minus 4 degrees. Therefore, temperature of bottom of the pond should be minus 4 Celsius. And we know that ice layer is increasing thickness in this side. Therefore, this temperature should be 0. When growing the ice layer, room temperature should be less than pond. It is a cold temperature condition. Given temperature value minus 5, less than 0 value. Then we can get minus 5, 0 and 4 Celsius. It is not minus 4, it is 4. Then answer is 2. A glass vessel of volume V is completely filled with liquid of volume expansivity gamma 1, gamma L. The volume expansivity of glass is gamma G. They have given gamma L is greater than gamma G when the temperature of glass vessel is increased by amount theta. The volume of liquid that expels from the vessel is gamma apparent equals to gamma real minus C alpha. We can use C alpha is gamma gas, gamma real is gamma liquid. Then we can obtain the apparent volume expansion. Delta V equals V1 gamma apparent theta. V1 is the initial volume. It is given as V. Gamma apparent is this one, gamma L minus gamma G theta. Then answer is 1. A liquid volume expansivity gamma forms a liquid thread of length L0 inside the tube made of material linear expansivity alpha as shown in the figure. Temperature is increased by an amount theta. The length of liquid set will become. We know that final volume equals initial volume into 1 plus gamma theta. We can substitute final volume, final cross-sectional area into length should be equals to initial volume, initial cross-sectional area into initial length is given as L0, 1 plus gamma theta. We can write A0, A2, A1 into 1 plus 2 alpha theta. A1 L0 into 1 plus gamma theta. Then we can cancel out A1 term and we can subject L0 into 1 plus gamma theta divided by 1 plus 2 alpha theta. Then answer is 4. A glass container with a narrow area of cross-section as shown in the figure is filled with a liquid of height h. The expansion of the container is negligible. The rate of change R of height with temperature theta is best represented by. We have to consider rate of change of R, height. The shape of the vessel is like this. From this point to this point, the rate of increasement of h is increasing like this, and from this point rate of increasement is a constant value. Then answer should be 2. A solid sphere at 0 degrees with volume expansivity gamma s is completely immersed and floating in a liquid at 0 degrees as shown in the figure. Volume expansivity of liquid is gamma L. The entire sphere with the liquid is cooled down to a certain temperature. Consider the statement. A. The part of the sphere will above surface of the liquid after cooling. Yes, it is correct. We know that when cooling, volume of both of liquid and solid is decreasing. When decreasing, volume density increasing, but increasement of density for the liquid is greater than solid. Therefore, A is correct. The magnitude of upthrust is acting on sphere will not change. Yes, it is correct. It is always floating on the fluid. Therefore, upthrust is equal to the weight. See, density of sphere will be greater than the liquid of after cooling. No, it is false. There is an increasement of density for both, but increasement of liquid is greater than increasement of solid. Then A and B only true. Answer is 3. A glass bottle of spherical shape. A vertical cross-section of which is shown in the figure consists of large cavity, a small spherical cavity of radius r, and narrow tapered tube of length L. The total volume of large cavity and half of the volume of small cavity are initially filled with water at 0 degrees as shown. The expansion of bottle is negligible. The variation of height h of the water surface measured from the level xi with temperature is best represented by. We know that from 0 to 4 degrees volume of water is decreasing and therefore height is decreasing. After that, volume is increasing. It should be like this due to like this because of the shape of given container. Then we can get fourth one is the correct answer.